Hello, welcome to Chapter 2, homework questions 113 to 117. This problem is a checkpoint for solving linear systems of equations. It will be referred to as checkpoint 2. Solve each of the systems below. So we have 4 different ones we're going to be looking at. Solve them different ways, hopefully, as well. So the first one looks like we can use substitution. We're going to substitute 3x plus 11 in for the y variable into the second equation. And then that will allow us to solve for x. So we'll combine our like terms, subtract 11 to the other side, divide by 4, and get x equals -2. We can then plug x equals -2 into either one of the equations, but we'll plug it into the first one to get y equals 5. So that's the ordered pair, -2, 5. On part B, we can do something very similar. We'll use substitution again. But on this one, be careful because you do have x minus y, which means it's x minus the quantity 2x plus 3. And that's equal to -4, so you do need to distribute the negative inside the parentheses to make sure it's x minus 2x minus 3. So then we'll get -x, add 3 to the other side, divide by -1, and we get x is equal to 1. Plug that back into either of the equations. Once again, I'll plug it into the top one, and we'll get y equals 5. So the solution to that system is 1, 5. Next, on part C. Now, part C we don't have a variable solved for substitution. We could, but we're going to use a different method this time. We're going to go ahead and multiply the second equation by, could eliminate the x or the y, but I'll eliminate the y by multiplying by -2. So my top one's going to stay the same, and then I'm going to multiply everything through by -2, and I do that so that my y values, when I go to add the two equations, they eliminate. So I get -x is equal to 12, divide by -1, and x is equal to -12, and then plug that back into one of the equations. I'll just go ahead and plug it in the top one. -12 plus 2 times y, or 2y I guess, is equal to 16. Add 12 to the other side to get 28, divide by 2, and y is equal to 14. So x is -12 and y is 14. And then we'll move this up a little bit here, and part D, same thing, we'll use substitution. Now this one, it looks like we're going to have to multiply both equations by a number. I'll eliminate the x on this one. I'll multiply the top by 3 and then the bottom by -2. And when you do this, remember we want to make sure that one of our terms is positive and the other one is negative, so that when we add, they just cancel each other out. And that's why I multiplied the bottom by -2, so that gives me a -6x plus 8y is equal to +4. So now my x's are eliminated. I'm left with 17. Y is equal to 34. Divide by 17. And that's supposed to be a 17. Y is equal to 2. Plug that back into one of your original equations. We'll get 2x plus 3 times 2 is equal to 10. Subtract the 6. Divide by 2. And x is equal to 2 as well. So the ordered pair is 2, 2. Question 114. Hannah's shape bucket contains that list of stuff right there. If she reaches in and selects a shape at random, what is the probability that the shape will meet the criteria described below? So at least 2 sides that are congruent. So let's go through here. Equilateral triangle would have 3 sides that are congruent, but at least 2. Isosceles right triangle, that would work. A regular hexagon, all the sides are congruent, so that's good. A non-isosceles trapezoid would not work. A rhombus has at least 2 sides that are congruent. A kite does as well. A parallelogram and a rectangle. So it looks like all of them except the trapezoid, which would give us a total of 7 out of 8 possible. The next one is a 2 pairs of parallel sides. So it doesn't say at least, but at 2 pairs. So we need to look for exactly 2 pairs. Triangles will not have parallel sides, so those are out. A regular hexagon, when you're looking at a regular hexagon, you're actually going to have a couple of different parallel sides. You have 3 of them, so we don't want to include that one. Next one is a non-isosceles trapezoid, so that will have one pair, so that's not working. Rhombus would have two pairs. Kite, no, there's none. Parallelogram would have two, and rectangle would have two. So it looks like for this one we have a total of 3 out of 8. And then on part C, at least one pair of parallel sides. So at least one pair, we can include the ones that we just have, but anything that has at least one pair. So the triangles are out again, but we can include a regular hexagon now because it has more than one. A non-isosceles trapezoid, that has at least one. A kite doesn't have any, so it looks like we added 2 more. So on this one, we would have 5 out of 8. Question 115, find the area of the trapezoid below. What strategies did you use? So we can use the formula that we discovered, 1/2 height times base 1 plus base 2. 1/2 times the height. Now the height is not given, it's right here. So we don't know what that is, so we will have to figure out that. We do have the bases though, we have 12, and then this whole thing, not just the 18, but the 18 and the 5, so we have to include that. So let's figure out what the height is. And since it's a right triangle, we can use Pythagorean Theorem to figure out what the height is. So we'll do 5 squared plus h squared is equal to 13 squared. So 25 plus h squared is equal to 169. Subtract 25 from 169, and that is 144. Take the square root, and the height would then be 12. So now we have the height, 1/2 times the height, and then base 1, we could say the 18 plus 5 is 23, plus the other base is 12. So half of 12 is 6, and then 23 plus 12 is 35. And then 6 times 35 is 210, and it's measured in feet squared. Question 116, use the relationships in the diagrams below to solve for x if possible. If it is not possible, state how you know. If it is possible, justify your solution by stating which geometric relationship you used. So since we're looking at a triangle in part A, and it's given us the 3 measures of the angles in terms of x, we can use the triangle angle sum theorem to say that all 3 of these angles, 3x minus 2 plus x plus 8 plus 2x plus 3, those all 3 should add up to 180 degrees. So if I combine my like terms, 3x plus x plus 2x is 6x. My constants would be negative 2 plus 8 is 6, x plus 3 is 9. Subtract 9, and that would give you 171. And then if you divide by 6, we get 28.5 degrees. Alright, on part B, we have 2 parallel lines cut by a transversal. We can use a couple of different things that we've learned. Vertical angles to show that those 2 angles are congruent to each other. And then this angle and this angle would be corresponding angles. And therefore corresponding angles are congruent as well, so their measures are the same. So we used vertical. We use vertical angles, then we use corresponding angles. And so now we can set these 2 angles equal to each other, knowing that they are congruent, so their measures are the same. Subtract the 4x, add the 28, and then divide by 2, and we get x is 23 degrees. And on the last one here, on part C, let's see what we are looking at. We have these 2 side lengths. Do I say these 2 right here are congruent? All right, we also know that this one and this one are parallel. So how can we maybe use that? And then also, you have a transversal. So how can we use that to maybe help us figure out x? And since these are these two side lengths of the triangle are congruent, then we know their angles are also congruent or equal. So let's see what we can do here. So I'm just going to start writing some things down that I see. This would be vertical angle, so that's 56 degrees. We also know that because it creates a straight angle, we can do 180 minus 56, and this would be 124 degrees. And we can't do the vertical angle on that side because this whole thing represents that vertical angle. So we know that whole thing is 124. So next, going to the parallel lines, since we know this line is parallel to this one over here. All right, we can look at this angle and this angle. Those would be corresponding angles, which means they're congruent, so that would be 56 degrees. And since those side lengths are also the same, we know this would also be 56 degrees, so then we can use the triangle angle sum theorem, and we can do 180 degrees is equal to 56 degrees plus 56 degrees plus x, and add those up and subtract to figure out what the x is. So we'd have 180, that would be 112, and then subtract 112 from 180, and that will be 68 degrees. So on that one we used a lot of different things. Maybe we didn't need all of them, but just started kind of filling out the picture, and it looks like we used vertical angles, straight angle, triangle angle sum theorem. We also use corresponding angles as well. Question 117. Find the minimum and maximum limits for the length of a third side of a triangle if the other two sides are 8 and 13. So if you remember in terms of what we did in class, there's a way that we can just calculate this, but it also I think helps to visualize it as well. So if I have 13 as one of my side lengths and 8 as the other, I could open these as far as I possibly could, and that would give me a total of 21. Now, I can't make 21 because then it'd just be a straight line, so we'd have to bend it up just a little bit, but anything less than 21 inches would be okay. So we would say that the max would have to be less than 21 inches. And then for the minimum, if I took this 8 and kind of rotated it back around until it laid flat on this side, then that would leave you with this little part right here, which would be 5 inches. So the minimum would be greater than the 5 inches. And then that answers the question. Once again, looking for the max and min values of the third side of the triangle.